أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم.
Comparing means independent sample t-test. In many real-life situations, we cannot determine the exact value of the population mean. Obviously, it's next to impossible that you can collect data on population for every particular situation. So what we can do is, we are only interested in comparing two populations using a random sample. So what you are interested in, or what you can actually do instead of collecting data on the whole of the population, what you do is you collect data on two samples. Such experiments where we are interested in detecting differences between the means of two independent groups, maybe male, female, junior ranked employees, middle ranked employees, or low income individuals or high income individuals. This particular scenario is tested using independent samples t-test. Now the two samples are independent of each other. Now some of the situations where independent sample t-test can be used are: an economist would like to compare the per capita income in two different regions in a particular country. Let's say I want to assess the per capita income between Lahore and Islamabad, Karachi and Lahore, Peshawar and Islamabad. So these are two different regions. A market researcher wants to know in which territory will his product be able to penetrate more. This will help him in deciding the right place to introduce the product. So he wants to compare two territories. You cannot have more than two territories. And those two categories will be used to compare any particular value. That may be sales, maybe expenses, maybe advertisement expenses, or any other dependent variable. These categories are referred to as independent, whereas the testing value or the mean value is referred to as dependent variable. A labor union wants to compare the productivity levels. So productivity level is your dependent variable and it's compared between two different groups. So let's say one group is permanent, the other is on daily wages. An aspiring MBA student wants to compare the salaries offered to the graduates of two business schools. He wants to assess who earns more. Business school 1 earns more, or the graduates from business school 2 earn more. Now in all of these examples, the purpose is to compare between two independent groups. What are the two independent groups here? Two business schools. What are the two independent groups here? These are the two different types of workers, maybe permanent workers or those who are on daily wages. So the purpose is to compare between two independent groups in contrast to determining if the mean of a group exceeds a specific value, as in case of one sample t-test. So in one sample t-test, your objective was to assess the differences in population mean, that was your test value, and your sample mean. In this case, we do not have any information regarding the population. So what are the assumptions for two sample t-test or independent sample t-test? There are several assumptions that need to be met for two sample t-test. These are basically the same as those for one sample t-test, starting with the most important and working down in decreasing order of importance. These are independence. Now these two groups must be independent of each other. Data in one group cannot be part of the data in the other group. So remember what we said in our discussion of one sample t-test. If the data are not independent, the p-values generated by the test will be too small. And even mild non-independence can be a serious problem. So your data must be independent in order to run this test. Value in one category cannot be part of the other category. Measurement scale, your dependent variable, the variable that is to be evaluated, as in the case of the example, salary was one of the variable to be evaluated, compared between two business schools. Productivity level is to be evaluated between two types of workers. Now these two variables are per capita income. Now all these variables must be either in interval or ratio scale. They should be numerical. Normality. The two sample t-test will produce reliable p-values if the variable is normally distributed in each population. However, the two sample t-test is fairly robust to mild departures from normality, and this assumption matters little when the sample sizes are large. So if you've got a large sample size, then you can have certain level of departure from normality. So even if your data is not normal, you can use two sample t-test. So how do you do this in SPSS? So here is our example. A study was conducted to compare the self-efficacy of the public sector workers. The researcher was of the view that there is no significant difference in their self-efficacy between male and female employees. So what is your dependent variable here? Self-efficacy. Because this is the variable to be compared between male and female employees. The null hypothesis in this case would be that there is no difference in the self-efficacy of male and female employees. So average self-efficacy score of male employees equals that of the female employees, so that there is no difference between the self-efficacy score of male and female employees. Because in null hypothesis, what you propose is that there are no differences, no relationship. So what's your alternate hypothesis? The alternate hypothesis would be the male employees significantly differ in their self-efficacy from the female employees in the public sector organization. So your alternate hypothesis is yes, there are differences between male and female employees in their self-efficacy. So how do we test these assumptions? Well, there is no statistical test to test the assumption. So how do you test your independence? Now each observation is independent. The two groups are mutually exclusive and independent of each other. Not even a single observation can be part of the two groups. That means there is independence. So self-efficacy is a numerical variable that is measured on interval scale. Why on interval scale? It was the responses were recorded on a Likert scale from 1 to 5. And there were 5 questions or 6 questions maybe measuring self-efficacy. And later those 5-6 questions were transformed into a composite variable. Normality. Now these are the assumptions of normality. In order to check this assumption, what you need to do is you need to make sure your skewness falls between this range and kurtosis falls between this range. Now in this case, the values are well within the range. How? Have a look here. Self-efficacy and your skewness is minus 0.993, which is within plus minus 2 range, and your kurtosis is 0.227, which is obviously within this range. And here are the references for your skewness and kurtosis values. So how do you run this test in SPSS? What we do is we go to Analyze, Compare Means and Independent Samples t-test. Now look here, test variable and grouping variable. In this case, the variable that we are interested in testing is self-efficacy. So we select self-efficacy, put it in here in the test variable list. And our grouping variable is gender, male and female. This will go in here. Now in this case, we have defined gender as 1 and 2, where 1 represents male and 2 represents female. Press continue and press OK. And here are your results. Now how do you analyze and interpret these results? In order to do so, what I've done is I've put them here in the slide. So let's analyze the output. The first table labeled Group Statistics gives descriptive statistics, that is number of data sets, mean, standard deviation and standard errors of mean. So you've got self-efficacy as your dependent variable between male and female. So there were 260 male respondents and 92 female respondents. The mean score for self-efficacy for male was 3.52 and the female was 3.7. The self-efficacy score of female is higher in comparison to male. The standard deviation 1.02, 0.71. This is fine because normally this should be less than half of the mean. But still we haven't checked the significance of difference. What we are interested in is checking the significance of difference. So where is the significance of difference? It's in this table, independent sample t-test. Now this is actually where you test your hypothesis. Now how do we test our hypothesis and what's the interpretation of this particular table? In this table we get the results of the two tests, Levene test for equality of variance and t-test for equality of means. Now here what we are getting is we are getting two different tests. The first one is Levene's test for equality of variance, whether there is equal variance between the two groups or not. Now based on this test we are going to test the equality of means, that is whether or not self-efficacy differs between the two groups or not. So based on your Levene's test of equality of variance, you check your hypothesis. So interpretation of this table is actually in two stages. The first stage, Levene's test for equality of variance. And based on this, we actually assess our hypothesis, whether our hypothesis should be accepted or rejected. How do we do this? The Levene's test tells us which statistics to consider to analyze the equality of means, because we are assessing the equality of means, whether self-efficacy is equal in male and female or not. How do you do this? You are actually comparing means. You are comparing the average values or mean values. So I am interested in assessing whether the self-efficacy score between male and female is equal or not. Now this is actually your equality of means. But whenever we are accepting or rejecting a hypothesis, we do so based on our significance value. But the problem here is we've got two significance values. Which one will we select? The top one or bottom one? In this case, the answer will come from Levene's test for equality of variance. A small value of significance associated with Levene's test indicates that the two groups have unequal variance. How small? Now in this case, this is 0.000. This is less than 0.05. If it's less than 0.05, this means Levene's test for equality of variance is significant. Anything less than 0.05 means that it is significant. Now in this case, we would say it is significant. This means that there are differences in variance between the two groups. What if this was greater than 0.05? Then we would have said equal variance assumed. In the given example, a very small value of this test statistic indicates that the two groups, male and female, do not have equal variance. Why are we saying that these two groups do not have equal variance? Because the significance value is less than 0.05. When this is less than 0.05, equal variance between the two groups cannot be assumed. This means that we are going to select this particular row to assess our equality of means. Therefore, the statistic associated with equal variance not assumed should be used to test the t-test for equality of means. Now we are going to assess whether the self-efficacy between male and female is equal or not. So once you have assessed whether the variance between the two groups can be assumed or not assumed, the next step is to assess whether your hypothesis that you formulated earlier, you are null or alternate, which one is to be rejected and which one is to be accepted. In this case, since equal variance was not assumed, this is the p-value that we are going to select to assess the equality of means, to assess whether self-efficacy is equal between male and female. Now look at this here. This is less than 0.05. If it's less than 0.05, we will say that the self-efficacy between male and female is not equal. There is a difference in self-efficacy score between male and female. Since this value is less than 0.05, we will reject our null hypothesis and we will accept the alternate hypothesis. And in this case, the alternate hypothesis is that there are significant differences in self-efficacy score between male and female. Now, the next question is, which one has a higher self-efficacy score? So there is a difference. So one of them will have a higher self-efficacy score and one of them will have a lower self-efficacy score. So where is that self-efficacy score? So if we come back here to group statistics, we can see that female have a higher self-efficacy score in comparison to male. Now if we change our hypothesis to male or females have a higher self-efficacy score in comparison to male. Now this is one-tailed because this is directional. Now how do you calculate p-value for such test? You just have to divide this significance 0.036 by 2. So this will give you one-tailed results. Moving on. The t-test result with equal variance not assumed. Why? Because this was less than 0.05. Shows t-statistic of 2.115 with a negative sign. With 229 1.196, that's your degree of freedom. The corresponding two-tailed p-value is 0.036, which is less than 0.05 but higher than 0.01. So it is significant at 5% significance level. Therefore, we reject the null hypothesis at 5% significance level and we are accepting the alternate hypothesis, which means that self-efficacy of male and female respondents are significantly different from each other. That is, the two genders do not have the same self-efficacy. The table also gives mean differences, that is the difference between self-efficacy of male and female, standard error of difference and 95% confidence interval of the difference. Now this is the mean difference. How much different is their self-efficacy? This is minus 0.20. And look at this, your 95% confidence interval. There is no zero in between. That's why the results are significant. How do you interpret this? If there is a zero between lower and upper value here, if there is a zero in between these values, then your hypothesis is, or your null hypothesis is not rejected. You fail to reject your null hypothesis. While the mean difference helps in observing the total amount of difference between the mean values for the two groups, the other two values are not much importance for practical purposes. We may recall our hypothesis we tested above. H0, which means male and female have got same self-efficacy. H1, that is they have got different levels of self-efficacy. Here we are only interested in knowing if self-efficacy of the male and female respondents is the same. The appropriate test for this would be two-tailed test. However, if we were to test the assumption that self-efficacy of workers of male is greater than the female, the null and alternate hypothesis would be different and we would need the p-value of one-tailed test. The new hypothesis would be H0, male and female have got same self-efficacy. H1, females have got a higher self-efficacy in comparison to male. Or another H1 could be male have got lower self-efficacy in comparison to female. The one-tailed significance value or p-value can be obtained by dividing the two-tailed value by 2. In this case, our p-value was 0.036. So if we divided it by 2, we will get our p-value for one-tailed test. Thus, one-tailed p-value in this case would be 0.018. Therefore, we reject the null hypothesis and conclude that self-efficacy of the workers of, or rather this is a typing error, self-efficacy of female workers is greater than that of male respondents or male workers. Right? And if we go back here and look at the descriptives, now look here the descriptives, and this shows that female have got higher self-efficacy score in comparison to male. So here is a slight typing error. This should have been female is greater than male. because our hypothesis is formulated as female greater than male. So the self-efficacy of female is greater than male. So this should read female and this should read as male.